So welcome everyone. My name is Larry Garfield. You may know me as Krell online. If you want to make fun of me on Twitter, that's where you do so. I highly encourage it. I'm the Director of Developer Experience at Platform SH. We're a continuous deployment cloud hosting company. I'm a member of the PHP Fig Core Committee. It's kind of like the United Nations of PHP standards body with all the good and bad implications that would have. And for the PHP developers in the room, I do implement PSR 8. For those who don't get that joke, join me in the breakout session afterward. I can explain it there. Right, so let's talk about clouds. Wrong cloud, sorry. I mean these clouds. The clouds that seem to be eating the world, or at least everyone says so. That, you know, cloud hosting is the next big thing. It's where you're going, it's where your software should be, and you need your software to be cloud native. Okay. What is cloud native? Depends on the marketer, but at the same time, you also have to ask, okay, what does cloud mean? What does it mean for something to be in the cloud? That's actually two different questions. First, there's what is cloud computing? Cloud computing is that's different from what is the cloud. These are separate questions, and they have separate answers. The cloud, with a capital C, is the marketing term for someone else's hard drive. This is outsourcing your computer hardware to some other company. And this is your pretty bog standard outsourcing question, and it has not really changed dramatically since the 90s. Arguably, some of the reasons to use someone else's hard drive have gone up, but they've also been reasons they've gone down. That's not really what we want to talk about today. What I want to talk about is cloud computing, which is a different thing and is based on the idea of abstracting away physical infrastructure. The idea with cloud computing is you no longer are thinking in terms of a physical box, a physical computer. You're thinking of a logical system, a logical computer that may or may not correspond to a physical piece of hardware. In fact, it's better if it doesn't. This is often, but not always, implemented using the cloud, someone else's hard drive, because it's a convenient way of doing it, but it doesn't have to be. You can do cloud computing on your own physical hardware if you are so inclined, or rent someone else's hardware. There's a lot of ways to skin that cat. You may have heard the phrase here that you want to treat your systems like cattle, not pets, so that they can be, you know, deleted and recreated on the fly. That's the same idea. That's what we're talking about here, that a full computer system is disposable at a logical level, not at a hardware level, which now lets you create applications that are similarly disposable. You want your application instances to be disposable. You want them to you want to be able to just delete them and create a new one on the fly easily and cheaply, because that lets you, that frees you to think about your application in different ways. Okay, so what makes an application cloud friendly? What makes a given code base or given application, a given tool, play nicely in this type of environment where systems are being created and deleted willy-nilly, and you don't really care about individual instances? This is a question that I've asked a lot. As I mentioned, I work at Platform SH. Part of my job there is working with various applications to get them to run nicely on platform. We're a cloud-based host. We are doing hosted cloud computing. And that means I get to see a lot of applications that do a really good job of it, and a lot that, if you can't say anything nice, don't say anything at all, so I'm not going to mention them. So based on that experience, what I'd like to do today is share with you some guidelines for making applications play nice in a modern cloud-based environment rather than handcrafted artisanal servers as if it were the 1990s, which a lot of programs are still written for. Now, I'm using Platform SH as kind of the background and experience here, but almost nothing I'm saying here is specific to Platform SH. That's more or less the same would apply to any host or even like your own custom-built system. And this is also, for the most part, language agnostic. I'm going to have a few language specific points, but for the most part, this is true regardless of what programming language you're working in. First rule, guideline. This one is more of a rule. Split your code from your content. What do I mean by that? Well, what is code? Code is stuff provided by the developer. It has been carefully tested because you are all doing proper test-driven development, right? I'm going to assume everyone's nodding. And it lives in a version control system, and that's the source of authority because you're all using version control, right? I'm going to assume everyone's nodding. And you want it read-only at runtime. You don't want your code to be modified in production because that's a security risk. That's an audit risk. Who has had the experience of, oh, someone logged into production to hotfix a bug that was really critical, and then it never quite made it back into the version control system, and now, oh dear, now that bug is back. That's what you want to avoid. That's why your code is read-only in production. And you want that at the file system level. Content, meanwhile, is provided by users of the system. It is frequently ad hoc. Users are not doing any kind of careful testing or version control. It lives not in version control, but in a database or on the file system, some kind of writable store. Doesn't matter what it is, could be an SQL, could be Mongo, could be Elasticsearch, doesn't matter. And you do want this to be writable at runtime. This could be a local file system of some kind, or it could be a remote file system like Amazon S3, doesn't matter. These are separate, and you need to keep them separate at the file system level. You do not ever want to have a directory that contains some files that come from Git and some files that come from the user pushing buttons. That doesn't work because that directory is going to be either read-write or read-only, and you can't mix the two. I have run into far too many systems where they have a single config file, usually it's PHP, that has both user configuration in it, where the user has picked settings through the UI, and system level configuration like the database credentials and stuff like that. And they put them in the same file and try to redirect that whole file from the application. Don't do that. That's bad. Please don't do that. That's a great way to introduce bugs and instability and lose user configuration. But at the same time, though, remember, your application is disposable. Your data is not. If your data is disposable, you don't actually have a production site, you have a testing site. This is roughly the workflow you're going to go through for any deployment. You have a place where you're doing your development, your local laptop or computer or whatever, and you're syncing the source code with a Git repository somewhere. And at various points, you're going to take the source code from Git, pull that out, and run it through a build process. That build process is going to turn the source code into a production artifact. Now, if you're writing in a compiled language, Go, Java, and so on, then that's your compile step. If you're writing in a scripting language, you still have a build step. Running composer install, pip install, bundle, npm, compiling Sass or less code, all of these things that are producing artifacts off of your source code is still a build process. There's still a compile step. And the output of that, you're going to plug into a production environment where there's already data waiting for the last time you plugged in a version of your code, your last build artifact. And then periodically, you're going to take your data and sync that back down to your development environment to make sure you're developing against relatively up-to-date data to make sure you don't break anything. You really don't get an in-between option between app and data because their workflow is different and distinct. So our first takeaway, cleanly separate dev-provided files and user-provided files. Things that come from the developer and things that come from the user have a different existence, a different workflow, a different way they are handled. Make sure there's a very clear, bright line between the two. But what about configuration? Is configuration code or is it data? Well, does it come from the developer or does it come from the user? Could be either. What's the canonical definitive source for your configuration? Is that in Git Or is it in the database? Could be either. Bespoke applications that are custom built generally don't have this problem because they don't bother building out user customizable screens. They just say, oh, I'm going to edit a configuration file and push it to Git. That is completely fine. That's a perfectly good way of doing it. In fact, for a custom built application, that's what I'd recommend. If you're dealing with an off-the-shelf application though, especially a content management system of some kind, then that gets a bit trickier. Very often for these pre-built systems, being able to push buttons in the UI to change configuration is the selling point. That is the whole reason for using that tool. Well, okay, that means that configuration is not something that you can version control because it's user-generated. It's user-generated content. It's user-generated data. And so it's not going to be in the database. That's something you're creating in production. So you can't use the same workflow for it. That's a problem if you want to back up your configuration. How do you handle that? Well, the least bad approach I've seen, the most robust approach I've seen, is Drupal 8, which has this extensive configuration management system where you can push buttons in the UI, and that writes data to the database. And then you can also take that and export your entire configuration table to a series of thousands of YAML files, which you can then commit to Git to push those to your production site and run an import command that sucks all of those YAML files in and puts them into the production site's database. This lets you push buttons in local development, commit that to Git, and deploy it that way. As I said, this works. It is over-engineered for the vast majority of use cases. I would not encourage this for most applications. Frankly, it's a lot better in most cases to just decide upfront where it originates. We talked about the difference between code and data. Configuration is one or the other. Decide which it is. There's a very good argument to be made for it being either one. It's going to be a different judgment in each case. That's fine. Sometimes you'll want it to be one, sometimes you'll want it to be the other. But decide and commit. If it's in code, but you get the idea. Decide and commit to the workflow for this configuration is the code style or the data style. You don't get to pick both. It's one or the other. Next, what happens at runtime stays in runtime. Forgive the Vegas reference. What do I mean by that? This is roughly how your environment is going to look. We have that application image, that build artifact we talked about before, that you're going to slot into your production environment where you already have a database, you already have your search index, you already have user-provided files, you already have all of this data, and your application needs to just kind of slot in there. Because when you upgrade it, what you're going to do is take out the old application, the old build artifact, and put in a new one. And this is conceptually, this could be shutting down a container and putting a new container in place, could be rebooting a container, lots of different implementation details around that. But your application needs to deal with the fact that it's going to run in multiple environments with multiple sets of this data. Why? Well, if you're doing dev, stage, prod, then dev, stage, and prod are 3 different environments with 3 different sets of data. You don't want to modify your application. You want your application to be able to plug into any of those without modification. Otherwise, you're not actually testing your application code correctly. You're not testing it in a mirror of your production environment. You would have to modify it each time. If you're doing a more robust testing model than that, like what Platform offers, where every branch is a testing environment, then you have a variable number of environments with an unknown name, and your application can't just have a switch statement saying, oh, if it's this IP address, I'm in production, if it's this IP address, I'm in testing. You don't know. The application itself needs to get told, here's a database and so on to use. If you're doing some kind of multi-head environment, you want to take your application and replicate it to do 2, 3, 4, 27 instances of it for scaling purposes. All of those applications need to be able to talk to the same data source reliably, and you want to take that same application image and just clone it any number of times. Potentially, that could even be happening automatically if you're doing auto-scaling. So your application may spin up new instances of itself without you even noticing. Your code has to be able to handle that. You need to assume nothing about the environment in which your application is going to run. How do you do that? By dependency injecting your environment. What do I mean by that? Database credentials should be injected. That includes SolarWredis, any external service, and the API keys you have, any paths on disk that you have to deal with. Relative paths are okay relative to the application root, but the root of the application, that's something that should be injected. Domain names. Please never put a domain name in the database because that's going to be wrong as soon as you clone the database to another instance. And yes, I have seen applications get all of these wrong. Ideally, you never know the credentials and keys for any of these services. You as the application developer don't know them. They could change on each deployment, and that's okay. How do you do that? Environment variables. That's the most straightforward way. Different languages have a different syntax for reading them. They're all basically the same idea. You don't necessarily control where they're coming from, but you also may not know the format they're in. Every host has its own format, and every application has its own format and may name the variables differently. And that's just the nature of the beast. There's no standard around these things, so different hosts name them different ways, different applications name them different ways. So you're gonna need some kind of glue code to translate the environment variables your host provides to the environment variables that your application expects. And this can be fairly simple, but you need to make sure there is a place in the application to put it. And this is code, not configuration. This is developer-provided glue code. So as an example, at Platform SH, we have our environment variables provided in, so the database relationship, database credentials are provided in a environment variable that's a base64 encoded JSON string, so you can connect to multiple databases. In old school, Symfony 3, it was as simple as this. This is PHP code. Don't worry about reading it in detail, that's not the point. All we're doing here is taking the environment variable, unpacking it, and then pulling out the database credential values, the username and password and host name and so on, and shoving those into the Symfony 3 container, because that's where Symfony 3 wanted it. Okay, so we do that. And then we pull out this entropy variable and shove that into the kernel secret parameter, because that's where Symfony wants it. Later versions of Symfony don't use the container parameters. They actually have environment variables that they look for. So this code is different, and it just takes our variables and maps them to the variable Symfony wants. Same idea. We've actually simplified that. And now in PHP, JavaScript, Go, Java, a couple of other languages, we have a utility library that does essentially the same thing. So in this case, if you're dealing with Express in Node, then grab the config library, pull the database credentials out of it, and just assign those to a MySQL create connection command, and you've got your connection, and then you go do your thing with it. Again, the specific details aren't the point. The point is your application needs to have a place where this can happen. And it's going to be different code for every application and for every host. For Go, same basic idea. In this case, you create a config object, create the runtime config for it to get that config object, and then you can pass that in to your application. All just variations of the same theme. The point here is that you have a place to do so. Okay, but what about local development? For local development, if your application is looking for environment variables, there's this wonderful standard called env-files, file called .env, and then you have a code library that when the application starts, first thing it does is look for that file. If there's an environment variable defined in that file that is not already defined as a real environment variable, it will pull those in. It just creates defaults. There's plenty of env libraries to pick from. Every language has several. Doesn't matter which one you use, pick one, I don't care. But for the love of God, do not check this file into Git. That is not what it is for. You never, ever, ever, ever use this as a config file in production. This is strictly for your local development. Your .env needs to be in your git ignore file if you commit your .env file to production, you are doing it wrong because you are then hard coding your application to a specific environment. Don't do that. Another thing to think about are trusted domains. Many applications have a feature that they will only accept requests if the HTTP header says it is for a specific domain of the production site. This is good. This is good for security. That domain name is different on staging and production and your other staging and local development and so on. So make sure you have glue code that can handle that dynamically depending on your environment. Again, that information should be provided through environment variables. Never put specific domain names in the database. I'd also recommend, a lot of systems are built to use constants of some kind to define these values rather than reading directly from the environment. Please don't do that. Constants are globals. They actually make doing overrides harder. They make the glue code more difficult to write. They make testing harder. Systems that are still in 2020 using constants to configure their environments are doing it wrong. Just please don't do that. It makes everything harder when writing this glue code. But the key point here, dependency inject your environment. Your application should not assume where it's running. It should be told this information through environment variables or similar. But what about user configured connections? What about letting the user just say where these services are? This gets tricky. The place you see this most often is in installers. Installers are easily the place that I run into the most problems because they make the most assumptions that are not correct in a cloud-based environment. What does a typical installer do? Your typical installer will ask for database credentials, ask the user for some basic site information, then it'll write that information to a config file somewhere, populate the database with whatever the initial configuration is, write some basic site info into the database, and cool, your site's installed. And this does not work at all in a cloud-based environment. Why? Well, everywhere we said write to file, you can't do because you have a read-only file system. And if it's not a read-only file system, then it's not code, it's data, but you want to have that configuration for the database connection safe from modification in case your application gets hacked. Oh, and by the way, you can't provide specific credentials because you as the user don't know what those credentials are going to be because they are different in every environment. So this doesn't work. The lazy answer is to install the application locally and then fiddle with it and then upload it to your production site. Fiddle with it is a terrible step. Don't do that. A much better approach for the installer, which not enough systems do. So if you're writing installers, please, please, please take notes right now. You'll make my life a lot easier. Pre-include the connection glue. That could simply be, that could mean you have something in place already for a particular host, or if it's a mainstream application that you're distributing to multiple hosts, just have a place where individual users can put in the glue appropriate for their hosts, whether that's Platform or Heroku or Amazon or Google or whoever, doesn't matter. And have the installer be smart enough to say, hey, I already have database credentials from the environment, so I'm not even gonna bother asking the user. I know what they are already. So I'll just be smart about it. And then don't download anything in the installer. If your installer is a basic GUI that then downloads the code in the background, that's not going to work when your production environment is read-only because you can't install code there. You can download data like translations or sample code or sample data. That's okay. But you don't want to have the installer downloading additional code because it has nowhere safe to put it. If it downloads it to a writable mount, well, one, that's not version controlled in Git, and two, that's now modifiable. One security hole in your application, and an attacker can now modify code in your application. You don't want that, I'm assuming. If you do want that, then we have issues. So if you're building an installer, do it this way. You also want to avoid lock-in. This is not as much a technical point as a business point. This is more speaking to the cloud part. but you always want to be able to take your business elsewhere. This is how you keep your providers honest. You're probably going to be using all kinds of service providers for your hosting, for third-party services, for authentication, whatever. That's okay. But make sure that you can take your business elsewhere. Even the ones you like, even the ones that you think you want to keep working with, they're in business for themselves, not for you. Which means use free software. Use things that you can replace if needed. Why? Because any of these services could go out of business. Any of these services could change the pricing on you in a way that you are not okay with. They could change their terms of service in a way you're not okay with. If your application fundamentally would not work without AWS Lambda, congratulations. You are now 100% dependent on Amazon Lambda. And if they change something, you are totally SOL. Think this doesn't happen? This is a list of projects that Google killed off as of 2015. I'm sure there's a whole other column here by now. Third-party providers, including your hosting provider, have their best interest in mind, not yours. You need to have your best interest in mind. And that means being able to take your business elsewhere quickly, if necessary, the threat of which then keeps your providers honest. Once your providers know that you have no opportunity to leave them, they can do anything they want to you. If they know that you could leave, if they start being jerks to you, they're less likely to be jerks. And I say this as one of those companies. Please keep us honest by using tools you could take elsewhere. How do you do that? Use open source tools. Use tools that you could install yourself if you wanted to. You're probably not going to install them yourself. You probably are not going to want to run these services yourself on your own hardware. But the fact that you could means you can also then hire anyone you want to host them for you. So if you're with one hosting provider and they go out of business all of a sudden, which has happened, or they change their terms of service and start being jerks to you, which has happened, you can just download your data and find any of 1,000 other hosts to put this stuff on. And you can be back up in business in a day or two. If you're using Amazon RDS, which is their proprietary relational database, DynamoDB or Cosmo, which are their document databases, any of these systems that you can't swap out in a day, then you are beholden to that other company. And that other company is now business critical for you, and that is not a good place to be. Have an escape valve, even if that means you have an abstraction layer in your application that translates what you want to do to that third party, as in a driver-like fashion. That's good. That gives you the ability to abstract away that dependency and makes it easier to change later if you need to. And having that safety valve is what can be, the more you have that safety valve, the less likely you are to need it. And if you need to invoke it, the easier it will be. And finally, everyone's favorite topic, microservices. You've probably all been to at least one microservices talk at some point in the conference so far. I'm going to probably annoy every one of the other presenters with this section. So be it. I mean, why am I saying microservices are a problem? Like, clouds enable microservices, right? Well, kind of. What is a microservice? When we say microservice, what do we actually mean? There is no industry consensus yet regarding the properties of microservices, and an official definition is missing as well. Thanks. Good. All right. So when we talk about microservices, what does it actually mean? The best definition I found is kind of an amalgam of Wikipedia and Martin Fowler. It comes down to this. Microservices are single-purpose components that communicate to each other over dumb pipes, not a proprietary protocol, not some dedicated system, but just something generic like HTTP, that are built by separate teams with their own independent release schedules. Fundamentally, a microservice treats every other microservice in its network as a separate third party that may as well be a different company. If you have one team putting out 5 different code bases that all talk to each other. That's not microservices. That's one team putting out five different applications. Now, this does have benefits. You can use different tools and languages for different parts of the system. It may make more sense to use Go over here and PHP over here. You can do that. But you have small, focused interdisciplinary teams. You have a Go developer and a database developer and an API engineer on this project. You have a front-end developer and a usability engineer and a PHP developer and a JavaScript developer on this one over here, and so on. You can have teams that are small enough to collaborate effectively, that if you were at the keynote yesterday, have a low communication overhead. You get a strong separation of concerns. If this application and this application are separate teams and separate databases and separate repositories and separate languages, it's really hard, not impossible, but hard to bleed responsibility between the two, which also makes it much easier to scale and evolve these pieces separately. If your user authentication microservice is getting a lot more traffic, you can scale that up without affecting any of the others. If you need to rewrite it from Python to Go to get better performance, then cool, you can do that and you don't have to impact anything else. All the others are talking to it over HTTP and nothing else. Basically, if you're familiar with Conway's law, any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. Basically, we're leveraging Conway's law to drive the architecture. If you have separate teams building something, then they will end up with separate products. If you have a single team building something, you're going to end up with a single application. That's just the way humans work. There's downsides, though. The biggie right off the top, network latency. Sending a message over a network is only about 1,000,000 times slower than calling another function in the same application. Do you really want to have that extra 1,000,000 times as much latency for an operation? When you add networks, you have many, many more points of failure, and that is points plural. When you're calling from one class to another, one object to another within a program, the only place that you can have something go wrong is in memory. Your problems are your code or basically nothing else. When you introduce a network, you have every single piece of hardware between you and the other end, plus every piece of software running on it, plus every physical connector between each of those, every single one of which could easily break. If you need a transition code, you need to refactor it and say, hey, this responsibility makes more sense in this microservice instead of that one. Well, guess what? They're different teams in different languages, so that is now 10 times harder. You have to rewrite it. You can't just move code around. You have to deal with API versions because these have separate release schedules, which means that, hey, I could be putting up a new version of the order system that has a new API that's way better than the old one, but the web front end over here is still running and it's talking to the old API, so I now have to deal with that problem. Whereas if it's all one big application, I don't have to worry about that because it's all one big binary and I can ship the whole thing at once. I don't care about internal APIs changing. That affects nobody else. You also absolutely need more staff because you need to have a team for each microservice. That means you need a project manager for each microservice. You need a technical lead for each microservice. You need developers with the appropriate skill set for each microservice. You can't just throw them back and forth between each other or dump them all in one pool. You're not doing microservices then. Depending on your language, there may be additional costs. PHP, I'm a PHP developer primarily. PHP is frankly poorly suited to microservices because each time, each request has a large overhead to start up the process and initialize all of your services and internally and so on. That is much higher than other systems that have a persistent process. Go, Java, or Node, anything that has a persistent process is much better suited to this rapid fire tiny request than PHP is. Basically, if one of your microservices going down means that others don't work, you don't actually have a microservice, you have a distributed monolith with all of the problems of distributed computing and none of the benefits. Great. Let's not do that. Okay, what do we do instead? I used to call this clustered application until I realized a much better name for it, multimodal monolith, which is much more fun to say. What is a multimodal monolith? A multimodal monolith, besides being a tongue twister that I'm impressed that I'm able to get through here, is built by a single team. And it has discrete components to it, but they all deploy at once. They're all in the same code repository, and they all go live at the same time in the same deployment. They are almost always in the same language. Not always, you can do some parts in another language, but it's much easier to just use the same language for everything. And they can share data stores. With microservices, your user system has its own MySQL instance, and your catalog has its own MySQL instance, and those are separate database instances on separate containers, and they do not talk to each other. With a multimodal monolith, it's okay. You can have them share a data store. This should sound familiar. You probably have already built a multimodal monolith at some point in your career. In fact, I would say most people have. Cron jobs. If you're running a cron job, guess what? That's a multimodal monolith, because that's work being done in the same application in a separate band. Many systems have a separate front controller for their admin application. Could be a separate whole other directory. It could just be a separate front controller. That depends on the language. But it's common to have a separate visible front end for the admin section and the public section. You may have work pushed off to a background queue using RabbitMQ, ZeroMQ, Beanstalk, Gearman, SQS, doesn't matter. It's some kind of queue worker that's handling background tasks rather than running them in the process. You may have a separate front end, not just for the admin, but also for API calls. So you have your web front end going through one front controller, and a separate front controller, possibly a separate application that handles API calls for your mobile app or something. These could be built in separate containers, but they can all scale independently that way. But they are still coming from a single code base. You still have a single code base that controls all of them. What do all of these have in common? What do all of these variations of multimodal monolith have in common? They are all happening at asynchronous boundaries. Any given request touches only a single service. A given request touches just the main customer web front end, or just the admin UI, or you have a process running in the background for the queue worker and it's just doing the queue. So if one of these goes down, that's okay. Everything else can still keep working because they only interact on asynchronous boundaries, either time or a database or a queue server of some kind. And you only need to do the work to respond to a given request in that process. I said before, PHP was not very well suited to a microservices setup. PHP is actually one of the best languages for this kind of setup, because it's really easy to have multiple separate front ends. It's really easy to fan out multiple instances, to take the same image, the same built artifact, and clone it a dozen times and use each instance for a different thing. PHP actually works really, really well here, frankly, better than a lot of the other languages do, because it's built on the shared nothing model. You can do it in any of these languages, but don't shortchange PHP. It actually works really well in this case. In summary then, what's the main takeaway? What's the main guidance I would give you for making your application play nice in a modern cloud-based environment? Don't assume things. Don't assume the environment your code is going to run in. Don't assume the number of web heads that you're going to have. Don't assume what the connections are going to be to a database or a search index or whatever. Don't assume the domain name that your system is going to be running on. Don't assume that you have any write access to the hard disk. Don't assume that third-party services you're using today are going to be there tomorrow. We've seen enough cases where they're not there tomorrow, and you need to be prepared for that. And don't assume that you're big enough for microservices. If you're not Amazon or Netflix or Google, those are the places that have deployed web and microservices effectively. Are you at the size where you are talking about Google level or Netflix level of traffic and engineering power. If not, you may not want to go microservices. You may just want to write a multimodal monolith and throw a couple more CPUs at it. That's going to give you a much better result in the end. Thank you very much.